Hello guys. Yesterday we discussed about the algorithms from the first section in the Art of Computer Programming book. Now we're gonna move to next section, that is mathematical preliminaries. It means like requirements or knowledge. Like what sort of mathematical knowledge is required for studying computer science. We're gonna go through all these concepts one by one. Especially, I just wanna say one thing. These are the things as defined by Donald Knuth. These are the ideas as defined by Donald Knuth, who is one of the greatest computer scientists and one of my favorite book writer as well. So we're gonna straightforward jump into the topic and gonna discuss the first mathematical concept that is required for programming. That is mathematical induction. Our first topic is mathematical induction. And the second thing that is required is knowledge of logarithms, and third thing is our series, fourth is our binomial coefficients, and fifth thing is our harmonic numbers. So briefly before starting, I just want to say that I I will not go through deep deep concepts that these things are based on. I will just briefly explain these things and move forward, because I suppose that if you are studying art of computer programming book, then you will definitely be already aware about these concepts. That's why you have chosen to study such a hard book in the world of computer science. So let's move on to our first topic, that is the mathematical induction. So let's discuss what does it mean by mathematical induction and how we can utilize this in our programming to understand the programming concept. So mathematical induction means that coming to a result based upon certain assumption. So this is called mathematical induction. That is, we come to a conclusion based upon a certain assumption. Like for example, we say if n square equal 1, then n can be plus 1 or minus 1. So here we assume that n can either be plus 1 or minus 1 and come to conclusion that n square is equal to 1. So this is the basic form that I can explain mathematical induction. The more complex formulas are always there, like some of the first n natural numbers, like we have 1 2 3 4 up to n, and it's n into n minus 1 by 2. I believe it's okay. 2 minus 1 1. I believe it should be plus. Yes, so it's like summation n is equal to n into n plus 1 by 2. We can reduce this formula, like we can say for n equal 1, summation of first one natural number, it's funny to say as well, so it's 2 by 2, that's 1. Now we can assume that if summation of k first numbers is k into k plus 1 by 2, then we assume this is true. Yeah. And from this we can conclude that if we add 1 to this, then that formula will also be true. I'm just gonna quickly go through that as well. So let's see. So we have summation, we have assumed that summation k equal k into k plus 1 by 2. Now we're gonna prove that k plus 1, if we do this, this should be equal to k plus 1, k plus 1 plus 1 by 2. I just put this into the formula, and here we go. So we need to prove that. So how we can write this? We need to prove this equal this. We're gonna prove this. Okay, so how we can prove this? We can say summation of k plus 1. How we can write it? We can say summation k plus what? Summation of k plus 1 numbers will be equal to summation of k numbers plus k itself. Then we're gonna put k over here. This is from our assumption, and we're gonna calculate it. K plus 1 plus 2k divided by 2, k square 2k, sorry 3k plus 1 by 2. When we factorize this, then we can say that k into k plus 2 by 2 is our result, and hence by starting with the simple assumption, we have proved that if we assume that this formula is correct for k numbers, then it will be correct for k plus 1 as well. So this is called mathematical induction. Now the basic question that comes to the mind of a student is how we can use this in the computer science world, because in computer science world as well, you need to make a number of assumptions, and based on that assumptions you need to come to certain results as well. For example, either it's defining the variables, or doing the summation stuff, or doing the computation, especially in the machine learning things. We need to derive certain conclusions from the certain data. So there we can use the concepts of the mathematical induction. So that's a very far point, that learning about machine learning and everything, and that's not not the today's topic. So let's move on to logarithms. Now I hope that you get an idea about mathematical induction and how it is used in the world of computer science. Let's move on to next topic, that is logarithms. I believe that I should use the pen and paper from now. It's not working. So we're gonna use some pen and paper for doing this. So we just move on to next thing, that is our logarithms. So why we use logarithms in the basic sense? To do the complex computations. What is the purpose? First question that comes to the student mind is, what's the purpose of having logarithm? Why the heck logarithm exists? What's the purpose? To do the complex computations. Why I am using word computation? Because we are talking about computer science, not about mathematics. So if we want to get 2 to the power 2.23, how we can find that? That's a complex question, but this can be calculated by computation through writing some computer programs, or nowadays most of the languages like C, Java, C++, or Python, or even PHP have got inbuilt functions, inbuilt libraries to do such kind of the computation, so that we does not need to write any specific function from the basic data types to calculate this. So this is the logarithm thing. Like if we want to calculate the log of 3 number, what's it, log of 2, what's it, these are the basic things with a specific base. But log can be with base like 10, we can say log 3 with base 10, log 4 with base 2. So we can say like this, these things as well. Now what does this mean? I just want to briefly explain, because log 2 of like 5, what's its value? What does it mean actually? It means that what will come over here. It means that base to the power something, base to the power this, will be equal to 5, and we gonna find this. For finding the logarithms, you can just use the log tables for general mathematics, and also in different languages like C, which is just go through, like even in Mix, that is the programming language that is talked about in the art of computer programming. We have got some specific steps to do these kind of complex computations. So this is the basic idea about logarithms. You just need to know these things, like what does it mean by logarithm and how we can leverage this in the computer science. Yeah, I hope that this will be clear to you. Now we're gonna move to our next topic, that is series. We're gonna discuss our next three topics in this at the same time, that is series, binomial coefficients, and harmonic numbers. Our next three topic is series, binomial coefficients, and harmonic numbers. So what does it mean by series? What does it mean by binomial? What does it mean by harmonic number? Series means that there is a specific pattern that we can observe in a string of numbers. There exists some kind of pattern. So if we say like 2, 4, 6, 8, 10, so there is some pattern in this. That's the meaning of series. So series is clear that if there is some pattern, like these are increasing by 2, this is called series. Now I just want to move to computer science scenario. Why we use series, why we talk about series in computer science? Because we will be dealing with 1 and zeros, and there will be a lot of ones and zeros. We will be seeing like 1 0 0 0 0 1 1 0 0 1 1 1 1 1 0 0, these kind of things, and there will be series of these bits which our computer can take like these bits and draw certain conclusion that this means, like suppose A in our alphabet, these series of bits means B. So there is something a relationship between series in the mathematical context and in the computer science context. And we have binomial coefficients and harmonic numbers. These we gonna discuss when we will be using further in the further top concepts of this book. So till then, please stay tuned with me. We're gonna discuss it when it comes to be discussed later on. That would be better to be discussed later on. Okay, so here we go. That's it for the day. Thank you for watching, and please go ahead and watch the first lecture if you are new to this series. I hope that at the end of this series you will be able to understand what is the basics of the programming, how does the programs in high language get converted into the lower languages like assembly and even to the machine code. Thank you for watching. Stay tuned for the next part.